Sir, I am not able to hear you. Sir, you are on mute.
Babu, sir?
Yeah. So your voice is audible.
Yes, sir. Yes, sir. Dr. Babu is also entered into the screen, sir. He was the organizing secretary come convener of this international conference, sir.
Yeah.
Already in the last year, he organized one international conference, and this is the second series, sir.
Sir, Babu, huh?
Babu, sir.
Good morning, Babu. This is Chaitanya Verma from Physics Department.
Babu, shall we start?
Sir, organizing committee, organizing secretary, huh?
Organizing chair, sir.
Organizing chair.
Organizing chair. Who is organizing secretary?
No, organizing secretary is not there, sir. Program chair also there from IIT.
Sorry?
Organizing chair is there. Organizing chair is not mine. Program chair is there.
Program chair.
Only one organizing chair, sir. By me only.
Okay, Anna.
Signed by Springer with me only.
Okay, fine. Okay, sir. Okay.
Sir, shall we start, sir? Chaitanya, sir?
The convener of the event, sir, once more, sir. Convener of the event, Dr. A. Ramarao, sir. HOD of CSE.
Convener.
Yes, sir. One more thing, sir. Please introduce all session chairs, session chair heads. They give wonderful support to conduct the event. Without their support, we cannot do the event because of the backbone pillars of the entire event of that entire credit goes to our chairs and reviewers also.
Yes, sir.
I am one of the third, sir. That means.
Okay, fine.
Sir,
you can start, sir.
Thank you. Today, it's my pleasure to introduce today's day.
Sir. Chaitanya, sir, just a moment, sir.
Okay.
So now, welcome to all of you. The second International Conference on Data Science and Artificial Intelligence 2023. So today we are entered into the second day, and this international conference jointly organizing by California State University, USA, and LENDI Institute of Engineering and Technology, Vizianagaram, Andhra Pradesh. And we are happy to announce the Department of Mathematics and Physics, Geetham School of Science, Geetham deemed to be University, handling the technical session 5. And yesterday we have successfully completed one technical keynote session as well as presentations also. And I extend my sincere thanks to our resource person, Professor Khadar, Department of Mathematics and Statistics, VT University, Vellore, for accepting our invitation to give a keynote talk in the present international conference. Now I am happy to introduce the moderator of the keynote session of international conference, Professor Chaitanya Verma Mudururi. Professor Chaitanya Verma completed MSc in Physics from Andhra University, and he completed a doctoral degree is also from Andhra University. Coming to his professional excellence, overall he has more than 18 years teaching experience in reputed institutes, and currently he is heading the Department of Physics, Geetham School of Science, and he had opportunity to deal with various physical science papers for BSc, MSc, MTech, MTech, and pre-PhD students. And Professor Verma published more than 40 research papers in various national and international journals with reputed organizations, and he has presented 7 papers in national and international conferences. And he guided 3 PhD students, and under his supervision, 3 more students are doing pursuing PhD. Now I am requesting Professor Chaitanya Verma to moderate the keynote talk. Thank you, one and all.
Thank you, Akri sir, and it gives me a great pleasure to involve in this international conference. And some very beautiful works have been shown today. And maybe today also, definitely there will be some more good papers will be coming up. And I want to introduce today the chief one, Dr. Khadar Babu sir from Vellore Institute of Technology, Vellore. He's an associate professor in the Department of Mathematics. He has completed his PhD from the Department of Statistics, Sri Venkateswara University, Andhra Pradesh. And during his tenure as a faculty, he has guided 7 PhD students and published around 84 papers in various international journals. Completed a paper from Space Application Center, Ahmedabad. And also, he received Best Alumni Award in Diamond Jubilee celebrations of Department of Physics conducted by Sri Venkateswara University. So his expertise in the statistics field will be helpful not only to his students who are being taught by him in at UG and PG levels, but today lecture will also give some idea for those new research scholars who are entering into this field. And definitely, I hope they will enjoy his lecture today. And thank you, one and all. And I request now Khadar Babu sir to please present his work. Thank you, sir.
Thank you, sir. Hello, my voice is audible, Sridhar sir?
Yes, sir. Yes, sir. Yes, sir.
Audible, sir.
Yeah. Thanks for your nice introduction about me. Respected convener of this conference, Dr. Ramarao sir, and organizing chair, Babu sir, and moderator, Professor Chaitanya Verma sir, and Sridhar Akeri sir, and all those who are attending today's conference. Very good morning to you. Today, actually, I'm going to give a lecture on outlier regression, outlier removal and detection technique only I'm going to give, because here nowadays big data plays a vital role. Because of this only, now in a data having many irregularities, but we have to identify some standard values and remove the value, then we get best regression model. So that topic only I'm going to highlight. And now, sir, PPT, Cesar sir,
Sir.
I'm going to share.
Yes, sir.
Is it visible?
No, sir. Now it is opening, sir.
Opening, huh?
Yes, sir.
PPT rotating?
No, sir. Kindly go for full screen, sir. Full screen.
Full screen only. Full screen only.
Yes, sir. Yes, sir. Yes, sir.
It's coming, huh?
Yes, sir.
Rotating also.
You can go down, sir.
Yeah. Okay, na?
No, sir.
Is it visible now?
Visible, sir. Visible, sir.
Ah.
Can you go down, sir?
Go down means where?
You can scroll down your cursor.
PPT, yeah. PPT, yeah. Yeah.
Yes, sir. Yes, sir. Yes, sir.
Okay, na? Yeah. Can I start?
Yes, sir. You can, sir.
Good morning to one and all present here. This is Dr. Khadar Babu, Associate Professor Senior, Department of Mathematics, School of Advanced Sciences, Wait University, Vellore. Today I am going to give a talk on identification and detection of outliers for best linear regression model to big data analytics. So actually here, if you want to take a decision about the data, we need a model. That model also should be a best linear model. So if the model is good, then we can get very good outputs also. So due to this here, every time we have to maintain the best regression model or best prediction model for data handling. That is important. So basically in big data, we are taking many steps. First step is collect the data. First, you have to define the problem. So after define the problem, we take a data from various sources. After taking the model, after taking the data, we have many models are available. Based on that, we can choose any one of the model for analysis, data analysis. So in data, it's not a simple, that means it's not a small, it's very big. The number of values, capital N turns to infinity. It's not a finite. It's not, we're not able to calculate even mean, median also. It's very difficult to calculate the measures. In such a case, here we're taking a sample from the population, that means from a big data, then we give all measures, then finally we can take all measures for the population or not by using a standard procedures. When we are adapting the procedure for big data, we have predefined models are important. We have an important procedure to choose a model. In such a case, when we are making a model, selecting a model, analysis of the model at the time of giving the inferences, we have to see the data, the reliable or not. If the data is reliable, we'll get very good results. Sometimes data may not be good, then we'll get bad results. So in such a case, every time we should maintain the data good, then again the model is also suitable for the data or not. Selection of the data, selection of the model is important for the data. So anyway, when we are making a model, selecting a model, but data handling is important. When we are handling the model, data handling, when we are handling the data, some of the values are far away to the crowd. Crowd means, so the values, all values are homogeneous in a particular way. If you see the particular way, the all values are scattered in a particular place. If the data set scattered in a particular set means the data satisfies a standard homogeneous property. But some of the values are far away to the crowd. So in such a case, we have to identify such values. Then again remove the values. Then we get best regression model or best linear model or best procedures also. So due to the one or two values far away to the crowd, far away to the linear regression equation, then we say that the model is not reliable for the data. In such a case, we have to remove the numbers. That means outliers. Then we'll get very good output also. So now today's session, I want to highlight on the following contents. So first I wanted to give what is a regression, linear regression. Then again data plots and transformations. Then again here for making a data, the data is split into the many parts by using box plot diagrams. Then again the different techniques to identify the outliers. So the main usually we are using scatter diagram and box plot. This is called diagrammatic representation of the data. So these are the diagrammatical methods to identify the outliers. But anyway, by diagrams we are identifying, but we need a mathematical procedures also. For mathematical procedures, we can take many procedures like residuals. Then again, standardized residuals, standardized scores. By using all these things, we can identify the outlier, then fit a best linear regression model. So see this here, the first content, regression, it is a statistical technique. Here, the average relationship between or the functional relationship between the two variables x and y is called a regression. So in such a case here, one of the important thing is the regression line should follow the straight line equation y equal to a plus bx, but here we are adopting the equation like y equal to beta naught plus beta 1x, let us suppose. So in this equation, usually beta naught is intercept, beta 1 is slope of the equation. So the same procedure, that means the straight line satisfies the properties, the same thing we can adopt for regression line also. So here some standard applications of regressions found in almost every field, including physical and chemical sciences, engineering, economics, finance, pharmacology, life and biological sciences, social sciences, and other fields of study. So these are the some areas of applying the concept. So in this here, we are taking simple linear regression model. So in such a case here, we are taking, in statistical terminology, we are calling this two variable linear regression technique or two variable linear model. So if we take three variable linear model, four variable linear model, so then again k variable linear model, like that we are taking. So here I am taking this simple linear regression model. Here y equal to beta naught plus beta 1 x, let us suppose. So that we can put in a graph. Then again all values are taking in a xy coordinate system. So the values are scattered on different parts of the xy coordinate system. Then again we can make a line in between the data set. So that line is called regression line. So here this is a simple linear regression model or two variable linear model. One is independent variable. So in big data analytics, we are calling this as an explanatory variable. Why is dependent variable? We are calling this is response variable. So it is a response, then again explanatory x. So like that we are calling these two variables. Then again you see this, if we take a beta naught and beta 1 are the constants, that means regression coefficients. So beta naught is the intercept. So the line here, this is the line. So this is called intercept. Then again this line is regression line. So if we take a data on this, so the data should be scattered around this line only. Why? Because so this line is showing the functional relationship between two variables x and y. So because of this only, the line is always passing through the crowdy values. That means the many values are scattered in a particular place. The line is moving in between the values. So that's why we're calling this is a functional relationship between two variables x and y. So this is called the relationship between the variables. So then again you see here, so the points, so these are the points around the line. So all the points scattered around this line. So the values, no value is far away to the line. So the values, all values are scattered around this line only. So this is usual procedure. Then we say that this regression line is best linear regression line. So for example, any one of these values far away to the line, then we find that value is called as an outlier. So therefore, in this case, in the present graph, it's good for linear model. Why? Because all the values are scattered near to the line only. So when we see this structure, the data satisfies the property of linearity also. Why? Because the values are scattered around the line only. Then again here, after fitting the regression line, then again that line is called a fitted regression line or the predicted line also. If you want to find any values in between the data set, easily we can apply this equation. Then simply we can substitute the explanatory, then automatically we will get the response values y. So then after that, here we can see the error EI, error equal to yi minus yi cap. Yi means already observed values, already the given data set. So initially we are collecting the data, so that data set is called as yi, that means that is the observed data, that your data is observed data. So after that we can build a model, then again substitute all explanatory variables, then we get new response variables, new response values. So that values are called yi cap. So let us suppose ei is the error or residual, so that equal to yi minus yi cap. So then again we find all these values for every data set. That means we have all values, y values are there, y1, y2, y3 and so on. Then again we have y1 cap, y2 cap, y3 cap, all values are calculated by using a standard regression model. Then we can find E1, E2, E3, E4 and so on. So this EI is called residual only. So these are the residual values. By using the residual only, we can see whether the data satisfies the property of homogeneity, that means homoscedasticity, or the data satisfies heteroscedasticity, or we can go for autocorrelation. That and all we can see by looking the residual values only. So that is called residual analysis, error analysis. So based on the error only, we can see the properties of the data, whether it is a heterogeneous data, homogeneous data, or autocorrelation we can apply, any one we can take it. So by using this only, we can see all these things. So after obtaining the least squares, see this here, y equal to beta naught plus beta 1 x. So in such a case, for obtaining beta naught and beta 1, we can apply a procedure. That procedure is called as ordinary least squares estimation. So in ordinary least square estimation, so here we are taking the derivative with respect to the regression coefficients only, not for the variables. So for this, here we can take one more step also. So the data should satisfy the least squares as well as one more thing, that is called, we are applying variance also. That means minimum variance. So the data satisfies OLS and minimum variance. Then we say the data estimates are called as best linear unbiased estimators. So that is called blue. Blue means best linear unbiased estimators. When we say that, so the data, by using the data, we can fit a regression model. Then again in that model, two regression coefficients, let us suppose beta naught and beta 1. So these two values are called estimates, linear estimates. By using least squares, then these are called so linear estimates. So the secondary also we can take one more property, it's satisfying. So that is called minimum variance. Then we say that these are called best linear unbiased estimates. So whenever the data satisfies these two properties, we say that this is called Gauss-Markov theorem. So by using Gauss-Markov theorem only, we are telling this only. So after this, here we can see the error. So error should satisfy the standard properties. So see this here, the relationship between the response y and the regressor x is linear, at least approximately. So that is the first one. So the error term epsilon has mean 0. Epsilon is always, the mean of the epsilon is always 0. Why? Because here we are taking y equal to beta naught plus beta 1 x. So that's why here this should, the error value is always turns to 0 only. The error term epsilon has constant variance also. So here the constant variance, so that's called sigma square. So variance should be constant also. So if variance should be constant, then the data satisfies the property of homogeneous. So that is called homoscedasticity. The data satisfies this property, then we call this is satisfying the property of homoscedasticity. The one more thing is the errors are uncorrelated. Sometimes it may be correlated, sometimes it's not correlated. Then again the errors are normally distributed. So the errors are distributed also. So that means it follows a normal distribution with mean 0 and variance sigma square. So these are the standard properties of the major assumptions of the regression analysis. These are the major assumptions. So here we are going to introduce outlier. Outlier means it is a outlier or bad values. We can say that outliers means the values are not good. The values can seriously disturb the least squares fit. So when we are fitting a regression model, so that values may affect also. So the observations fall far away from the line implied by the rest of the data. So the all data are scattered in a particular place, but some of the values are scattered far away to the regression line. In this time, we can remove and identify and remove this value, then we'll get very good regression model also. So this is the definition of outlier. So then again here, the appropriateness of the model is studied and the quality of the fit. So see, so when you say the model is good, that is important thing. So for model validation, we are taking one more standard measure. So that is called R square. So this is adjusted R square, R square. That means the coefficient of determination. We are calling this as the coefficient of determination. So this only it is useful for saying that the model is best or not. That we can take a decision. So R square value usually it is in between 0 to 1. If R square equal to, let us suppose 0.9, let us suppose. So in such a case, in statistically, we are telling that 90% of the data involved to build a regression model. So we can give the conclusion. If R equal to 0.5, let us suppose 50% of the data involved to build a regression model. So that is also one more thing. So here we take a decision about the data set. Why? Because whether the model is good or bad, that is the important thing. If 90% of the data involved to build a model, which means that all data sets should be applied for this model. So therefore, so all data set involved. So then we say that this model is best regression model or best linear model for data set. We can take a decision. So for this, we are taking R square only. So then again, see this next one is outliers. So outliers are observations that appear inconsistent with the remainder of the data set. So it may be a mistake, else accurate, but unexpected observations also occurred in different parts of the XY coordinate system. So here some examples are given. So these are the some diagrammatic phenomena is given here. So see this, some of the values in the first diagram. So see this is the bar diagram. So this value is far away to the data set. All values are scattered continuously, but some gap is there. Then again, the value is scattered here. So then we say that these values, the values occurred here are outliers. So in this, the people are standing here. So this is the crowd. All are standing in a particular place, but some of the people are standing far away to this crowd. So this is the crowd. These are the far away to the crowd. So therefore, these people are outliers in this case. So if you draw a scatter diagram, so this is x-axis and y-axis. So the values, all values are scattered here, but two of them are scattered far away to this crowd. So in such a case, here these two values are outliers. Then again, if we make a normal curve, so in such a case, all the points inside the normal curve, but one point with red color is outside the normal curve. So therefore, we can choose this value is called outlier. So here, this is only the diagrammatic representation. By using the diagrams, we can say these values are outliers. So by using diagrams only, we are finding the outliers. So that means identification is the important thing. So either identify or detect. That is the detection is secondary. So these are the some standard diagrams. So this is also diagrammatic representation of the data set. So therefore here, so these are the outliers. The first diagram here, these people are standing far away to the crowd. So therefore these values are outliers. Then again in XY coordinate system, red colored dots are far away to the crowd. So therefore these two are called outliers. Then again here, see this is the graph. This is also outlier. So then again all points within the normal curve. So one point is only the outside the normal curve. Then we say that this point is outlier. So these are the outliers in this diagram. Then again here, after this, we have concentrated on outlier detection methods on linear regression models. Especially, we are concerned with observations that differ from the regression plane defined by the bulk of the data. See here. So if you want to find the outlier, simply we go for scatter diagram. Then again, the values are scattered in different parts of the XY coordinate system. We can identify and remove it. Then you go for fitting. That means we can fit a regression line Then you go for whether the regression line is perfectly suitable for the data or not by using R square, the coefficient of determination. So okay, graphically we can do all these things, but mathematical also we can do. That is important. We need mathematical structure. We need mathematical methods to identify the outlier. So therefore here it is important to identify these types of outliers in regression modeling, because the observations when undetected can lead to erroneous parameters estimated and inferences from the model. So see here, after fitting the regression model, you go for hypothesis, whether the beta naught is correct or not, whether the beta 1 is correct or not, by using t-test, by using f-test, by using analysis of variance, we can see whether the regression coefficients are perfectly suitable for the line or not. We can take a decision by using different statistical tests. So because of this only, here simply if you do not remove outlier, so then automatically you will get errors. Then every time we can reject also. So that is also happening. So because of this only, we should remove first. We should remove and make a regression model. That is the important thing. The standard outlier procedures are based on residuals. So see this. So outlier finding completely depends on the residuals only. So that is by using error analysis only we can identify it. So here you see this. Usually we are using these standard procedures. Methods of outlier detection in regression, usually we are taking residual analysis, the first one. The second one is residual plots. So such as graph of predicted residuals, the Williams graph and rank it QQ plot. So these are some graphs only. We are taking some graph. Then again we can see and we can identify the outlier and remove it. Next one is scalar measures of also influence statistics, such as Hooke's D measure. Then again, this is also some of the standard measures we can identify residuals, outliers. So the diagnostic based on residuals. First, how to diagnostic outlier by using residual. So the residual, it is denoted by EI. EI equal to YI minus YI cap. YI values are the observed values. YI cap values are predicted values. Then we can find EI values. So if the value EI is big, that means it is more than, that means it is a very big value. Then we say that, so this value is outlier. But there is no standard procedure to take a decision about outlier in this case. Of course, it is a residual, but we don't have a standard procedure to take a decision about the outlier. So this is the first method. Then again, you see the second method. So in the second method here, the standardized residuals. So these are the mathematical techniques to identify outliers. So in this case here, where first we calculate all observed all error values, E1, E2, and so on. All error values we can find. Then again here one more measure, mean squares. Residual error sum of squares we can calculate, MSRES, we can find it. So that is called sigma yi minus yi cap whole square by n minus k. That is the formula for MSRES. The formula for MSRES is sigma yi minus yi cap whole square by n minus k. K is the number of regression coefficients in the data set. So by using that, we can find di values. Di equal to ei by square root of MSRES. So where MSRES is the mean square residual. So this is the mean square residual, we can take it. Then again we take a square root, then automatically we will get di values. So these di values we are calling these standardized residuals. So here this is also having mean 0 and approximately unit variance. So this also satisfies an important property. So di is also follows normal distribution with mean 0 and variance also approximately variance 1. So because of this, we are calling this is also standardized residual. So here after calculating all di values, usually in statistics, so these standardized residual values always keep less than 3 only. So if large standardized residuals, let's call di greater than 3, potentially indicates an outlier. When we say it is an outlier, if DI value more than 3, simply we can say that it is an outlier. So here we are identifying the outlier. We need a standard procedure. So if we apply error residual concept, but there is no standard procedure to identify the outlier, we are getting some values, error values. If error value is maximum, then corresponding Y observation, corresponding X observations are residuals. Then again we can are outliers. We can remove it. That is only the procedure. But we don't have any standard concept to take a decision. But in standardized residuals, we have a standard procedure to take a decision. So the procedure is, it is a standard normal variate. So this also follows normal distribution with mean 0 and variance unit also. That means unit variance. Approximately, that is important, approximately unit variance. So because of this only, this DI value should be less than or equal to 3, satisfies the property. But if DI value greater than 3, we say that the values corresponding this X and Y are potentially indicates an outliers. So then immediately we can remove it and make a regression model. So our 3 variable linear model or 2 variable linear model, any model we can make it. That is one concept. So see this, here I am giving 3 important concepts. One is residuals. The second one is standardized residuals. Third one is standardized scores also. So see this is also one of the important thing. So this is just advancement of standardized residuals. So in this case, transformation of the random variables, X is a random variable. Then again here we are taking transformation of the random variables X to Z. Then Z is called standard normal variate. So if the standard normal variate Z, when it is a standard normal, if it is a standard normal variate, so then again Z follows normal distribution with mean 0 and variance 1. It satisfies this property. Z follows n 0, 1. So if X follows normal distribution with mean mu and variance sigma square, then automatically Z follows normal distribution with mean 0 and variance 1. So that is the property satisfied by the standard normal variate. So in the previous also it satisfies that property. Then again we say that the values are less than or equal to 3. Then we say that these values are perfectly suitable for the model building. So if any of these values DI greater than 3, we say that the corresponding XY values are outliers. First you remove it, then again build a model. That is the previous concept. So the same concept here we are applying. So see here, we wanted to be a Titan procedure to find the outliers. So because of this here, so they given many variables. Let us suppose for 2 variable linear model, here we are taking Y equal to beta naught plus beta 1 X. So if we take 3 variable linear model, we can take Y equal to beta naught plus beta 1 X1I plus beta 2 X2I plus epsilon, let us suppose. So like that we are taking. If we take 4 variable linear model, Y equal to beta naught plus beta 1 X1I plus beta 2 X2I plus beta 3 X3I. So like that we are taking. So here number of variables equal to number of constants also we are taking in this case. So including dependent variable, that means response variable. So 3 explanatory variables, 1 dependent variable, then both are, we can take it, then we say that 4 variable linear model. So we are calling this as a 4 variable linear model. Any model we can take it, either 2 variable or 3 variable, it doesn't matter. But here for every variable we can find xi. For example, here for 2 variable linear model, we are taking y equal to beta naught plus beta 1 xi. Let us suppose for this, for xi values we can find xi minus mu by sigma. For yi values also we can find yi minus mu by sigma. Then automatically, let us suppose here if you apply xi, that this follows normal distribution with mean 0 and variance 1. So this y also follows new yi, let us suppose, follows normal distribution mean 0 and variance 1. Why? Because here we are taking xi minus mu by sigma. So this is called standard normal variate. So we apply standard normal variate for x. Then again standard normal variate concept for y also. So then these two xi, yi are called standardized scores. So these are the standardized scores. So when these two are standardized scores, then automatically, so these values are always should satisfy the property like all the values are in between plus or minus 3 only. So if the values are in between plus or minus 3, we say that the values are perfectly suitable to build a model. So if the values, some of the values outside these ranges, then we say that these values are outliers. First we identify and remove the outlier, then regression model. So then only we'll get very good regression model also. So why? Because here the data we're taking from the population. So but the population data, that means the entire data, the big data, automatically it satisfies a standard property. For example, the loans of farmers in a particular bank, let us suppose, taken by the farmers in a particular bank, a particular agriculture loan, let us suppose, we can taking only the agriculture loans taken by the farmers in a particular bank. So there's some list is coming. So this is homogeneous only. All people took a loan for agriculture purpose only. So that is only the data satisfies the homogeneous. So because of this, if you take a data from that population, so that should satisfy the all properties of the population also. So the sample satisfies the properties, the same properties population also automatically satisfies. So if the technician is also different, so then again I'm giving an example here. We see this example. Hence we have used a new approach without using residuals. The performance of new approach was verified by using the real life data set based on medical data pertaining to the age and systolic blood pressure. So systolic blood pressure, SBP values were taking. So then again 30 people of different ages was retrieved from the website of some Florida State University by taking this data from that website only. So in this case here, the increase in blood pressure with age is mostly associated with structural changes in the arteries and especially with large artery stiffness, which is associated with increased cardiovascular risk. So that is also one of the important things. So here on the average, systolic blood pressure increases with age, while diastolic blood pressure increases to age 50 and then decrease also. So like that is taking that. So the age group and the SBP values I am taking for analysis. So see this is the data. Here I am taking 30 values. So the first person age 39, then again systolic blood pressure is 144. The second person 47, systolic blood pressure is 220. So like that we are taking this entire data. So this is the first set of the values. Then again second set, third set, like that 30 sets we are taking. That means 30 people were taking the values. So after that here we see this. After that we can fit a regression model. So that model is y equal to beta naught plus beta 1x plus epsilon. So that is here for the data y cap equal to 98.71 plus 0.97x. This is the regression model. So for this regression model, when we apply the regression model, then we calculate R square value, the coefficient of determination. So the coefficient of determination here, R square equal to 43% we are getting. So 43% means where y is the systolic blood pressure and x is the age, let us suppose. Here already we have taken the data from population. So here 43% we are getting R square equal to 43%. So it means that, so 43% means, so the value is 0.43 only. So that we can take into 100, then automatically we'll get percentage also. The R square may be the value in between 0 to 1 or the value in between 1 to 100. Any value we can take it. It's not a problem. Anyone we can take it. It's not a problem. So then again here, the coefficient of determination is having also very good methodology. So obtaining R square is also, it is under very good mathematical methodology. Here we need to calculate 1 minus residual error sum of squares, residual sum of squares. That means the regression, if you take regression sum of squares divided by total sum of squares. So that formula, if you apply that formula, then automatically we'll get the R square value. So that erroneous value we can calculate, deduct from, that means subtract from 1 only, 1 minus that erroneous value. Then automatically we'll get R square value. So once we get R square value, then we can give the conclusion also. So it means that 43% means 43% of the data involved to build a model. So that is one of the important thing. So then again, if you go for hypothetical testing, so then again here, if you want to test whether the value 98.71 is right or wrong, whether we can accept this value for predictions or for and forecast, whether this value 0.97 we can accept or we can consider for prediction and forecasting of the data set. So then we can apply some standard procedure is called hypothesis. So in hypothesis also we can take it whether this value is right or wrong. H naught beta not equal to 98.71. So this means that here this value test whether is there any effect effect of the change of effect on X, maybe effect on Y or not. So if you want to test whether is there any effects, if you change the value of X, then the change of Y. So we see the effect also, we can go for testing of hypothesis. That is called test for beta naught, test for beta 1 by using T test as well as F test. So after going for after finishing the T and F test, then finalize this model is perfectly suitable for the data. We can suggest for forecasting also. So this model is good for predictions. Like that we can suggest for forecasting. So for this here, the main measure is R square. If R square equal to 43%, so 43% is very less, which means that 43% of the data involved to build a regression model, the remaining data is not satisfying, like that only. We are taking statistical inference only. So statistically we are telling that 43% of the data involved to build a regression model. So this is the conclusion for 30 observations. So here we took only the 30 observations. For example, if you take y equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So any variables we can take it, not only one variable. One variable means one explanatory. If you want to take many explanatory also. So for many explanatory also, we can go for test for beta naught, test for beta 1, test for beta 2, test for beta 3. For all regression coefficients, we can go for test for all the regression coefficients. Then finally, all regression coefficients accepted, the hypothesis accepted, then only we can make this model is perfectly suitable for the data. So that is one of the important thing. So because of that only, we can consider this model for predictions and forecasting of the data set. So therefore here 43% is not a perfect measure. Then again we need to increase. That means we need at least R square value 0.6 or 0.7, 0.8. Sometimes if R square value is 0.99, 0.98, we say that the model is overfitting. It's not perfect. Of course, it's exactly perfect. But we're calling this is the model is overfitting also. We're giving the conclusion like that. So the model is overfitting. So like that also, we can take a decision. This is the data. For this data, then again we can find standardized residuals. We have already given 3 methods. One is residuals. The second one is standardized residuals. Third one is standardized scores. So the standardized scores for xi, standardized scores for yi, then we can see the value. So this value is too much high. That means, so here the lot of difference between the data set. Here for error residual value is 75.7. So this is 4.48. This is 0.12. So this is 3.48. So therefore this value is a little bit more. So then we can remove this value. We can identify and remove. So this value may be an outlier. Then again we can remove it. So after removing that, we go for calculation. So see this here in this table also we can observe that E2, this value is 75.65. E2 value is very large. Then again the standard residual D2 is also 4.45. So it is also exceeds the cutoff. The value is greater than that. This value is always all the values. These are the standardized values. Always keep inside the limits only. So 4.45 is greater than 3. Then we say that it is outlier. Then again you see the standardized Y score also. This is also 3.43. So this is also exceeded the cutoff value of greater than 3. So therefore here the observation said the data point 2 is considered as outliers. So these values were considering, so this age 47, then again this SBP 220 are the outliers. So then again after removing that, so see this sometimes we go for one more diagrammatic representation, that is called box plot diagram also. So in this box plot diagram, so the blue area means this is the crowdy. All the values are scattered in this area only. Why? Because our regression model is mathematical representation of entire data set. So because of this, almost all values are scattered here only. So if any of the points scattered above this green, so then again below this green, we are calling these values are outliers. So this diagram is called box plot diagram. So then again, if you take a regression line, so then again this value is far away. That means this value is far away to the all the crowdy values. So here all the values are around the regression line, but one value is far away to the regression line. So then we say that this value is outlier. Simply we can say that this value is outlier. These are the diagrammatic representations. So after that, here you see this, the standard values. So we are taking this value, R square value, so that is 0.43 only. So for these 30 values, so these are the statistical, and this is the statistical analysis, descriptive measures. So among all these things, I am taking R square only. It gives the conclusion. So the R square value is 0.43 is very less. So it means that 43% of the data involved to build a regression model. So that is the conclusion for this. So therefore, this value is very less. So then we can remove that value, then we see what happens also. After removing that, what is happening? So here we are taking 29 observations. So then that value is removed. For 21 values, we calculated all the measures, standardized residuals, standardized scores also. But in standardized residuals, all values keep inside the limits, plus or minus 3. Standardized scores also, all values keep inside the limits, plus or minus 3. Standardized scores for Y also, all the values keep inside the limits. So therefore, so then we go for model fitting. What happens, we'll see. Then again, simply you see that after removing this is the regression curve. So this is the scatter diagram. So the all values are scattered near to the regression line only. So then again you see this. So this is the squared R value. So if you remove here, we removed only one observation, not more. So out of 30, we removed only one observation. Then R square increased 0.43 to 0.71. See this, how much it changes. So initially it's 0.43 for the previous data. So after removing, the R square value is 0.71. So it is a drastic change, 0.43 to 0.71. So then 0.71 is the accurate value. Why? Because it's not fall the area of overfitting also. Of course, R square may be 0.99, 0.98 like that if you get. So then the data satisfies the model is satisfies the property called the property of overfitting. So therefore, this value is moderate value, 0.71, 0.8, 0. Less than 8. Usually we are taking, these are the moderate observations. So then we say that 0.71 is the moderate value. Then we say that 71%, which means that 71% of the data involved to build a regression model, simply we give the conclusion. So this value, based on this value only, we can accept the model for forecasting. So here we need a model for forecasting. Prediction, we can take any model, of course, but finally we can suggest for forecasting. So that is important. For forecasting purpose only, we are taking this value. So because of this, we are considering R square for validation, model validation, whether this model is considered for the data set or not. So by using this R square only, we can say that the model is perfectly suitable or not. So then see this, R square value 0.43, then again automatically R square value is 0.71. So which means that 71% of the data involved to build a model. So therefore the model is accurate. It's a very good model. Like that we give the conclusions. So after removing the outlier, so R square value automatically increases. So due to this, so every time we have to remove, first identify and remove the regression models. So that is the important thing. So we have only these techniques only available to remove outliers. So either grammatical, that means graphically or mathematically. So if you want to go for graphically, you go for scatter diagram, then again box plot diagram, like that only. That also useful to identify outliers. So mathematically, we go for residuals, standardized errors, that means residuals. Then again, standardized scores also useful to identify the regression models. So this is the today's concept for my talk. So then again, thank you very much. Any questions?
Thank you, sir. Any questions from the audience? Please, any questions from the audience? So the work Khadar Babu sir have presented is very wonderful, because these times many people are using this machine learning techniques, and they have to do the regression. They have to know the proper kind of regression model that they need to use based on the kind of problem that they are actually solving. So some of them, what we have seen yesterday presentations is that they are doing good work, but they are not able. Some of them not able to actually fit the correct regression model to identify the pros and cons of their machine learning model or deep learning model.
Yes.
Your presentation today definitely helps all those who are now listening to your lecture. Definitely helps in clearly not only selecting a deep learning model or a machine learning model, but also to properly identify correct regression model to reduce the error as well as increase the learning rate and getting better accuracy. Right. Thank you, sir. And still, please, sir has given a very nice presentation to most of you. It's very, very helpful. I request anyone please to ask some questions. One or two questions. Sir, I want to ask you one question.
Please.
From their point of view. Suppose if somebody is doing let us say that handwritten image detection model, maybe using a CNN or RNN.
Yeah.
Right. Which kind of regression will be more helpful?
Sir, here what I am giving, regression, that is common procedure. That is different.
Yes,
what I am telling is, if you want to build a model, not only regression, sir, any model. If you want to build any model, first initially we are collecting the data from different sources. So in that data, we can identify the outlier first. Some values are not related to the data set. Then again, we can remove it. Then only we'll get a very good model. Either maybe a CNN, any model. That's not a question. Any model we can take it. But so if you want to fit a perfect model, the data should be perfect. So here this is called data testing. So data testing. So here we can remove the bad values. That means outliers. Then we can fit any model. So finally, model is good for the data or not. I adopted in this case R square value.
Yes.
So by using R square only, I can say that this model is good.
Okay.
That concept I give.
So, thank you, sir, for giving a very nice lecture today, and hopefully this recorded one will be more helpful for all the participants today. Sir, both Babu, sir, you want to
Sir.
ask anything?
Khadar Babu, sir.
Say,
Thank you very
Thank
much,
you, sir.
sir.
Thank you, sir. Thank you. Thank you.
We will invite you furtherly.
Sure, sir.
Maybe next year, this November also, we are expecting the same cue from your end, sir.
Sure, sir. Sure. Whenever you want, you please call me. I will come
Thank you
and
very
give a
much, sir.
lecture. It's not a problem. Okay.
Definitely,
Thank you.
sir. I will be in touch with you.
Okay, sir. Thank you.
Thank you,
Thank you
sir.
so much.
Thank you very much.
So, thank you all, and the technical session for paper validation will be held evening 6:30. Right now, sir, Babu, sir.
Yes, yes,
Sir,
sir.
one-
Sir,
one more,
sir.
one more announcement, sir.
Sir,
One more,
okay,
sir. Sorry for the disturbance. Sir.
sir.
PhD session.
I have a
Babu?
class. Can I leave?
Yes, sir. Yes, sir.
Yes,
Thank you,
yes,
sir.
yes.
Thank you. Sir.
Thank you, sir.
Thanks.
Immediately another session is started. Please join the another session.
Okay, sir.
Okay.
Thank you.
Thank you very much. Please join another session immediately. Group link already link is available in the group. Please join.